In this problem, we'll do a more advanced example of transforming a graph. On the right side of this picture, I've given you the graph of y equals square root of x. Now, based on the graph of y equals square root of x, we are to describe the shifts that take place and sketch the graph of the function 2 times square root of negative 2x plus 4 plus 1. Note that the function we've given you has a square root, and it also has x, which I'm outlining in blue now. All of the other numbers will be modifiers on the original graph of y equals square root of x. Before we do anything else, let's mark down some key points on the graph of y equals square root of x and see how we can transform them. We will note that the graph begins at the origin at the point 0, 0. Also, we'll note that that's connected to a curve, and that curve passes through the points 1, 1. If we go further down the line, it will pass through this next point, which I'm marking now as 4, 2. And at the very end of the picture, it also passes through the point 9, 3. Now that we've marked down all of our points, let's examine our modifiers in this function. Before we do anything else, first let's note that there is a number in front of x inside of the square root. The previous examples we've done did not have this, so this example is a little bit more advanced. Before we continue any further, let's first factor out that number from both of the terms inside of that root. Inside of the root, we have negative 2x plus 4. If we intend to factor out negative 2, we will divide both terms by negative 2. Then we'll write that negative 2 outside of a new parentheses. We'll begin by writing that new negative 2 and writing our parentheses, and then we'll carry out the divisions. Negative 2x divided by negative 2 will give us x, and 4 divided by negative 2 will give us minus 2. We'll use this information to rewrite that square root. Now that square root will change to negative 2 times x minus 2. We'll still have the plus 1 on the outside. Now we take a closer look at our modifiers. The plus 1 on the outside denotes a vertical shift, which moves our graph up or down. Remember that vertical shifts affect y, and that plus 1 on the outside means that all of our y's will go up by 1. So we will add plus 1 to all y. The number in front of our square root denotes a vertical stretch. In the event of a vertical stretch, we're going to multiply all of the y values by whatever number is in front. Since we have 2 here, we will multiply 2 times all the y. This minus 2 inside of the parentheses denotes our horizontal shift. Remember that a minus inside of the parentheses denotes a shift to the right, and so this entire graph will be shifted right by 2. But also remember that if we're going right, that's adding to the x value, because right is the positive direction, so we'll be adding plus 2 to all x. Finally, let's draw attention to the negative 2 that is inside the square root, but outside the parentheses. This modifier is called horizontal compression. Think of this as the opposite of the stretch. Rather than multiplying y, we'll be dividing all the x values. Since we have a negative 2, we'll be dividing all x values by that number. Now, before we perform these operations, let's have a look at our order of operations. Remember that in the order of operations, the inside of the root will be operated before the outside, and multiplication takes precedence. For that reason, we'll begin by doing the horizontal compression as our first operation. Then the horizontal shift will be our second operation. After that, we'll handle the stretch, and finally the vertical shift. We'll copy down all of the key points I've written in red on the graph as well as all 4 operations on the next slide. Here I've listed all 4 steps for our operations and the starting points in the lower left corner of the slide. Our first operation is to divide all the x's by -2. This means the y values for this step will not change. Our y values will still be 0, 1, 2, and 3. If we divide all of the x's by -2, 0 divided by -2 still gives us 0. 1 divided by -2 will give us -1/2. 4 divided by -2 will give us -2. And 9 divided by -2 will give us -9/2. Second step is to do the horizontal shift where we add 2 to all the x values. This means for this step the y values again will not change. They will still be 0, 1, 2, and 3. If we take 0, our first x value, and add 2, we'll get 2. -1/2 plus 2 will give us 1.5, or 3/2 if you wish. -2 plus 2 will give us 0, and -9/2 plus 2 will give us -5/2. Now we move on to step 3, where we multiply all of our y values by 2. This means for this step the x values will not change. Whatever they were in the previous step, they will stay that way. For each of the y's, we multiply them by 2, so 0 times 2 gives 0, 1 times 2 gives 2, 2 times 2 gives 4, and 3 times 2 gives 6. Our final step, the fourth step, is to add 1 to all of the y values. This means once again the x values will not change. Therefore, if we start with a y of 0, 0 plus 1 gives 1, 2 plus 1 gives 3, 4 plus 1 gives 5, and 6 plus 1 gives 7. These are our 4 new points, and using those 4 new points, we'll now open another slide and draw them on a graph and connect them with a curve. With our points in order, we will begin by marking 2, 1 on the graph, starting by going right 2 and up 1. Then we mark 3/2, 3, remembering that 3/2 is 1.5, and so we'll go halfway between 1 and 2, and then we'll go up by 3. Then for 0, 5, we will go straight up on the y-axis by 5 units. And then for our final point, -5/2, 7, we'll take -5 and divide by 2, and that is -2.5. -2.5 will be halfway between -2 and -3. So toward the left we will mark 2 spots, and then the third spot, and halfway between them will give us our -5/2. Then we'll go up by 7 units, so 2 above our previous point, and we'll draw a mark. Finally, we'll begin at 2, 1, and draw our curve pointing left. And so this is the transformed graph of y equals square root of x, taking into account all 4 modifiers. Thank you for watching. We'll see you again soon.